To understand what rigor mortis is, unfortunately, we have to look at some Latin. Rigor is the Latin word for rigid. Mortis is the Latin word for of death. So together what we have when we have rigor and mortis is the rigidity of death. pH, though, is actually an abbreviation of potential hydrogen. That's English in case you did not recognize it. Everything scales on the pH scale. Pure acids go down to 0. Pure bases are at 14. And everything falls in between. Blood, I was surprised to find out, is not a 7, is where I thought it would be neutral. It's slightly base at 7.3, 7.4 in that area. Water is actually neutral at 7. If you look, you'll see that stomach acid is actually around 1 or 2. And if you have heartburn, which is actually excess stomach acid or whatever, you can counteract that by taking a base and dropping into the acid, and they neutralize each other by exchanging, hydrogen atoms. That's the potential of the hydrogen, them passing the atoms back and forth. So if you look over here, you'll see that stomach tablets like Tums and such are around a 10. So you throw the 10 and the 2 and you average them together, what's that, about 6? Look at that, huh? That's almost neutral. Very cool. Very cool how math works, isn't it? Hopefully when you die, you see something like this. A light at the end of the tunnel, and happiness and warmth, and angels singing, and family members there to greet you, as opposed to darkness and dread and unpleasant things at the other end of the tunnel. But I suspect this is probably what we're all going to see. The question is, though, is exactly at what time does death happen? Does death happen all at once? Didn't you get the memo? Not everybody gets the memo. Our cells continue to work until they don't. And to understand how rigor mortis works, we now have to understand how muscles work. You have your choice here of how you think muscles may work. Is it magic? Is it luck? Or is it chemistry? I'll wait while you think that over for just a moment. Was that enough time? Okay. If you answered chemistry, winner, winner, chicken dinner, you got the answer correct. Muscles work, as does the rest of the body, by employing chemistry. The smallest part of a muscle, the muscle strand or the muscle fiber, is called a sarcomere. Now, in that sarcomere are rows of proteins that kind of interlace. There are thick and there are thin filaments. The thick filaments are called myosin. The thin ones are called actin. And the way the muscle contracts is they slide past each other. The myosin is anchored to what's called the M line, and the actin is anchored to the Z line. So when they slide past each other, they pull the sarcomere in from the edges and contract. When you have all these sarcomeres lined in together, they contract the muscle.
Although the action between the filaments is described as sliding, the myosin filament actually pulls the actin along its length. The cross bridges of the myosin filaments attach to the actin filaments and exert force on them to move. This action is known as the sliding filament mechanism of muscle contraction. In this model, the sarcomeres shorten without the thick or thin filaments changing in length. A contraction begins when a bound ATP is hydrolyzed to ADP and inorganic phosphate. This causes the myosin head to extend and can attach to a binding site on actin, forming a cross bridge. An action called the power stroke is triggered, allowing myosin to pull the actin filament toward the M line, thereby shortening the sarcomere. ADP and inorganic phosphate are released during the power stroke. The myosin remains attached to actin until a new molecule of ATP binds, freeing the myosin to either go through another cycle of binding and more contraction or remain unattached to allow the muscle to relax.
Now that the body has ceased respiration, there's no longer any oxygen going into the body. And that's a key component of producing ATP and ADP, which is the engine, as you saw, of how the myosin grabs the actin and pulls and makes the muscles work. Okay, so there's no oxygen coming in, so there's no more ATP being made. So what happens while there, I mean, and there's no blood circulating, of course, too, now that the heart has stopped. Although ATP can still be produced for a short period of time by a process called anaerobic glycolysis. But at some point, there's no more ATP to be had. And the ATP is what causes that myosin to release its grip and let the muscle relax. So what happens is, as we die, that myosin is in this position holding that actin. And the fact that the myosin won't let go of that actin is what causes rigor mortis to set in. Now let's talk about the postmortem pH shift. As we said earlier, the cells don't get the memo. They just continue to work as long as they have an environment in which they can survive. And as they continue to work, they continue to produce waste. And waste is not carried away because as we saw earlier, the circulation system is no longer working. So at some point, their own waste, well, two things happen. Number one, their own waste poisons them. And number two, they aren't refreshed with new nutrients and oxygen to continue on the process of respiration at the cellular level. So what happens to pH in the body when this process goes on? Here, this is not going to be pretty, but it will be illustrative. Time is going this way, and pH, we'll say 14 is up here, and 0 is down here, okay? Lovely, lovely artwork. Now, since blood is about 7, we'll put that here in the middle, but we'll just do 8, 9, knowing that this continues up, right? Pop, pop, pop. And then 6 would be here, 5, dot, 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 on down. Okay, so our body's chemistry is right here, as we said earlier, about 7.3, okay? Let's call that homeostasis, right? Now what happens is over time, since those cells are producing waste, which is acidic, the pH starts to go down towards the acidic realm. Well, then the cells stop at some point because they all die, so it levels off. Now this is time, remember. Here's the time of death, and here's the time of death plus. At some point, the cells start to die and start to decompose, releasing all of their internal components, the enzymes, the chemicals, everything that's inside of them. So then what happens is that then shifts the pH from going acidic back up, and it actually goes past our homeostasis line of 7.3 and then continues on up some point to where it eventually just kind of levels off or stops, right? Because you're dead. Part of the decomposition here, the body breaking down and starting to just decompose, is the little heads on the myosin, which are still holding on to the actin, degrade and break apart and let go. And when they decompose and they let go, because of the shift in the pH in the body and the cells dying and all that, now when they finally let go, the actin is released and then the body goes back to being limp. And that's all I have for you on my report of rigor mortis and the postmortem pH shift.